The elevators are now important nowadays because our country is constructing big establishments like malls, condominiums, and high-story office buildings. That's why we, the students of Mapua Institute of Technology under Electrical Engineering, made a study about elevators.
The elevator is a type of vertical transport equipment that efficiently moves people or goods between floors of buildings, vessels, or other structures. Elevators are generally powered by electric motors that either drive traction cables or counterweight system, like a hoist, or a pump hydraulic fluid to raise a cylindrical piston like a jack.
Most elevators work just like a pulley. A very strong metal rope is joined to the top of the elevator car and goes up through a sheave in the engine room above the elevator.
The sheave is like a pulley wheel with ropes in it to hold the ropes tightly. On the other side of the rope is a weight, which is about as heavy as the elevator car when it is half full. This balances the car so that not too much energy is needed to move it.
An electric elevator with a motor at the top has a multi-strand cable weighing 4.5 pounds per feet. When the car is at the first floor, 180 feet of the cable are paid out, and effectively 0 feet are out when the car is at the top floor. How much work does the motor do just lifting the cable when it takes the car from the first floor to the top?
So our problem says that we have an elevator. So the elevator. It says that the strength or the force of this cable is 4.5 pounds per feet. And the first condition is that when the elevator is at the first floor, let's say that this is the first floor, the length of the cable is 180 feet. And when the elevator is at the top most floor, the length of the cable of the elevator is 0 feet. So we are asked to find the work done of the electric motor of the elevator. So it is easier for us to find the work done when we know the formula for work or by integration. So the formula for work by integration is work is equal to the integral of the function f of x dx from a to b. So this is the formula. So we will let our function f of x be the formula for work. And we know that the formula for work is force times displacement. We know that our force is 4.5 pounds per feet. And our distance or at this scenario, since the elevator is moving up, we can call this displacement. So we don't know our displacement, so we let x be equal to our displacement. So now that we have this, we now solve for the work. So work is equal to the integral of the function f of x, which is the formula for work, which is 4.5 x dx. So from a to b. So we will let our a from a to b. So that's 180 over 0. From 180 to 0. But since this will give us a negative value of work, and there's no negative value for work, so we can interchange the value. So we can now solve for work, which is equal to solving for work, we must integrate. So 4.5 x squared over 2 times x squared over 2 which is 1. then we substitute the values. So 4.5 times
180.
squared over here squared over 2. And this would give us, put it here, and this would give us 72,908 pounds. So that is now our work. So how is this work related to electrical engineering or to electricity? So we all know that work is equal to force times distance. And this force in electrical engineering is the horsepower. So the horsepower determines the voltage of an electrical thing. After this, work is equal to force times. So as you can see, they are directly proportional. And after this, we have power is equal to work over time. So power is directly proportional to work. So if we relate this, since force is directly proportional to work and work is directly proportional to power, the greater the force, the greater the work, the greater the work, the greater the power is required. So, but this is for power only. But power in electrical engineering is IV, which is current times the voltage. And you can see here that power again is directly proportional to voltage. So again, force is directly proportional to work, and work is directly proportional to power. And voltage is analogous or is similar to the work done by the object. So which means that as the voltage increases, the power increases, and as the work increases, voltage increases and power increases. But as we said, this is only one factor because we also have the I, which is directly proportional, and I is the current. So we must also determine how much electrical current is flowing in order to determine power. So it is not voltage alone that we must consider. But as we said, voltage is similar to work, and so knowing the work, we can determine how much power we need. That's it.
It is necessary for electrical engineers to know the work done by certain object, especially an elevator. Because this is one factor that will determine how much voltage the object needs or how much electrical power it requires.
Today, everywhere we go, you could see high-rise buildings, skyscrapers, and other establishments. People go to and fro those buildings on a daily basis. And thanks to the innovation of the elevators, people, even the elderly and the persons with disabilities, can easily go up and down the building. This technology must be well maintained, and this is where we engineers take place, primarily because elevators are operated through electricity. We engineers must assure that these elevators are working properly to ensure the safety of the public.